In section 3, we begin looking at something called a biconditional, and we also look at what makes a good definition. A biconditional is a single true statement combining a true conditional and its true converse. Remember, a conditional is something we can write in if-then form, and converse would be taking that if we had if A then B and switching it around, if B then A. Now, if it's true either way, we can rewrite it that we have A if and only if we have B. So a biconditional should allow us to write it either way and still be true. And basically to put these words if and only if between them. For example, we have this statement: a point is a midpoint if and only if it divides a segment into two congruent segments. If we look at this as two conditional statements, we could think of it first as if a point is a midpoint, then it divides a segment into two congruent segments. So I have a midpoint, that means it must be dividing into two statements. That's true. And if we look at the converse of this, so switching the order around, if a point divides a segment into two congruent segments, then it is a midpoint. That's also true. So regardless of the order, this will still be true, so we can still say if and only if. Now, this is also a good way to write a definition. If we can write something as a biconditional, then it can be a definition also. For example, this one we were looking at, midpoint. So the definition of midpoint is that it divides a segment into two congruent segments. Therefore, if we find something that fits, something dividing a segment into two congruent segments, really it is referring to a point, then we know that that point has to be a midpoint. So a good definition is something that will help us classify an object or identify it. And it has several important things to look at. For one thing, we use clearly understood terms. It has to be precise. Therefore, we avoid words like large and sort of and almost, which are subjective terms. And it's also reversible. That means that we can write it as a biconditional. We can write it either way. So if we're asked to write a biconditional statement, we want to think of this in 3 steps. First, we write a conditional. So, is this definition of a quadrilateral reversible? A quadrilateral is a polygon with 4 sides. So we think of the conditional. If a figure is a quadrilateral, then it must have 4 sides. And that's true. The second one, if a figure is a polygon with 4 sides, so if something has 4 sides, what is it? Well, that's a quadrilateral. Therefore, that's also true. So since the conditional and the converse are both true, that means we can rewrite it as a biconditional. A figure is a quadrilateral if and only if it is a polygon with 4 sides.